Hi, this is Priyankesh, and today I'm going to start the very first trial class of IGIDR Entrance Exam 2021. In this class, I'm going to cover the topic differentiation, which will be covered in two parts. So let's get started. So I'll start with the syllabus first. In the topic differentiation, we'll have to cover several subtopics which comprises of differentiation like sum and difference rule, followed by product rule, quotient rule, chain rule, differentiation of log, exponential and implicit function, and then followed by parametric form. So today I'm going to cover these topics first in first part, and rest of the topics I'll cover in the second part. Okay, so let's move to the next slide. So first of all, we need to understand what is differentiation. Okay, so for example, let's say we have a function, let's say y equals to fx. Then differentiation basically represents the rate of change of y per unit with respect to change in x, and it is defined as dy by dx. So there are different notations which is given by different mathematicians. Like Euler's notation is dy. Here d represents dy dx. Okay, we pronounce it as d dx or dy by dx. Okay, Leibniz notation is, which I have already mentioned here, dy by dx. Lagrange's notation is f dash x. So all three are same. If I'm saying dy, or I say dy by dx, or I say f dash x, okay, these all three are same. These are just different notations given by different mathematicians. Okay, let's talk about the rules of differentiation. So there are several rules which I have mentioned here, and I've also shared the formula sheet in our classroom as well. So let's see what are those formulas. So here, if I take the differentiation of any constant term, so it will result in zero. Okay, this represents the sum and difference of two functions. N- for differentiation of sum and difference of two function, what we have to simply do, we have to simply calculate different first functions differentiation, then followed by second functions differentiation. If I talk about, let's say, function is multiplied with any constant, so we're not going to differentiate the constant term, we'll simply differentiate the function only. Okay, let's say if this is called product rule. Okay, this is product rule. In this product rule, what you have to do, simply the formula is first function, then differentiation of second function. Okay, then plus second function followed by differentiation of first function. So this is called product rule, and this is called quotient rule. Okay, quotient rule. This is called quotient rule. And what is it? It is second term ka whole square. Let's say this is second and this is first. So second whole square, then you have to write second function, then differentiation of first function. Okay, minus first function into differentiation of second function. So this is these product rule and quotient rule are important. Then if we have a, let's say this is called chain rule. This is chain rule basically. Okay, so these all rules are very important. So let's say you have a function, let's say here it is mentioned f of gx. So what you will do, you will first differentiate f dash x. It will be simply f dash x. Then you will differentiate the second function which is inside the fx. Okay, so that is gx. So you will differentiate gx. Okay, I'll make you understand when we'll discuss some examples. Okay, let's move to the next formula. This is a very simple formula, like d dx of x to the power n. So what is happening here? Here n is coming in the beginning, and in power 1 is getting subtracted. So the d dx of x to the power n will become n x to the power n minus 1. Okay. Then next formula is d dx of e to the power x. So it's very simple because differentiation is remains same. But this formula is very important. d dx of a to the power x. It is a to the power x ln a. Okay. Next formula is ddx of log x. So it is 1 upon x. Okay, so this product rule, quotient rule, chain rule, and this ddx of a to the power x, these are very important. Okay, so you have to remember these formulas. Let's move to the next slide. So there are some other rules of differentiation as well. First one is trigonometric, and then is inverse trigonometric. Okay, inverse trigonometric. So first we'll discuss trigonometric. Let's say ddx of sine x is cos x, and ddx of cos x is minus sine x. Okay, ddx of tan x equals to sec square x. ddx of cot x equals to minus cosec x square x. Here CSC square, it stands for cosec square x, and ddx of sec x is sec x tan x. ddx of cosec x equals to minus cosec x into cot x. Talking about inverse formulas, so ddx 1 upon under root 1 minus x square. Then ddx of cos inverse x equals to minus 1 upon under root 1 minus x square, and ddx of tan inverse x equals to 1 upon x square plus 1. Then ddx of cot inverse x equals to minus 1 upon x square plus 1, and ddx of sec inverse x equals to 1 upon mod x under root x square minus 1. And whereas ddx of cosec inverse x equals to minus 1 upon mod x into under root 1 minus x square minus 1. Okay, here you need to see that these two formulas. So here this one is plus and this one is minus. Okay, similarly for tan and cot forms a pair, this one is plus and this one is minus. Similarly sec and cosec forms pair, this one is plus and this one is minus. Okay, so these are the formulas that you need to remember. Now let's begin with some examples so that you can understand how you are going to apply these formulas while doing differentiation. So first example, let's say you have a given function, let's say y equals to x cube plus 2x plus 5. This is the question, and they are asking for the differentiation. Here I am denoting differentiation as y dash. Okay, this y dash represents d dx, dy by dx. Okay, the d dx of y. Okay, so while doing differentiation, in as you can see that there are three functions 1, 2, and 3. This one is x to the power n form. This one is product into x to the power n form. This one is constant. So the differentiation of x cube will 3 will come ahead, and in power 1 will be subtracted. So this will become 3x square. In this will become 2x, because here x to the power 1 will come in front, and 1 minus 1 is 0. So any term having a power 0, it has a value 1. Okay, and the differentiation of constant term is 0, so here it will be 0. So final differentiation will become 3x square plus 2. So this is based on basically the sum and sum of the uh, sum of the function for differentiation. Okay, let's move to the second example. So let's say we have y equals to 2x plus 1 ka whole cube. This is the function. So this is here I'm going to apply chain rule, because you can see that this is the form of let's say if let t equals to 2x plus 1, so this will become t cube. Okay, so first we'll apply for this t, then we'll apply for x. So what we have to do, this will be y dash, if we y, and if we have to find y dash, so this will become 3t square. But again, what we are getting here, we are getting here dt by dx. So again we have to apply, so this will become 3 what 3 t value is 2x plus 1 into dt by dx. If we have to find out dt by dx, so dt by dx will become 2. So this is the thing, so answer will be 6 multiplied by 2x plus 1. So this is the chain rule, because here there is one function inside the another. Okay, let's move to the next example. So example, let's say 3. So we are going to apply the product rule. Let's say we have a function 5x cube plus 3x minus 1 in a one bracket, and another bracket we have x minus 1. So assuming this as first function and this as second function, as product rule says, first into differentiation of second function. So let's write the first function 5x cube minus plus 3x minus 1 and differentiating the second function. So second function has x, then minus 1. So differentiation of x will be 1 and differentiation of minus 1 will be 0. Then plus, we'll write second function and we'll differentiate the first function. So first function is 5x cube. So again, the x cube is in the form of x to the power n. So 3 will come ahead. So 5 into 3 and this will become x squared. Okay. Then we'll differentiate 3x. So I have already mentioned the how to differentiate x to the power 1. So this will become 3 and differentiation of a constant term will be 0. So let's solve it. So this will become 5x cube plus 3x minus 1 and we'll have to multiply it by 1, so it will remain same. And here in this x minus 1 and this will become 5 3 is 15 x squared plus 3. Now let's solve it further. So 5x cube plus 3x minus 1. Now you'll multiply x into 15x squared, it will become 15x cube. You'll multiply x into 3, so it will become 3x. Multiply minus 1 into 15x squared, so minus 15x squared, then minus 1 into 3. So this will be minus 3. Now let's sum all the similar terms. So this will become 20x cube followed by minus 15x squared, then 3x will become 6x, and then minus 1 and minus 3 will become minus 4. So this will be the final answer for this. Here we have applied product rule. Okay, so keep this thing in your mind. These kind of a question you are going to get in your IGIDR exam. Okay, maybe a level of question will be slightly difficult or it could be slightly easy. Let's apply to some chain rule to some other question as well. So let's say we have a function y equals to tan 2x plus 3. So differentiating this, as we already know that TDX of tan x is sec square x. So this will become sec squared 2x plus 3. Here you can see that ideally this function has to be tan x, but here it's not x, it's 2x plus 3. So we have to apply the chain rule. So we have to differentiate 2x plus 3 again. So this will become 2, differentiation of x is 1 and differentiation of constant term is 0. So final answer will be 2 sec squared 2x plus 3. Okay, let's move to the another example. Let's say y equals to, this kind of a question has been already asked in IGIDR once. So y equals to cos x cube. Okay, so we have to, again this is a kind of a we have to apply chain rule for the finding the differentiation. So y dash will be differentiation of cos x will be minus sine x, but here it is x cube, so we'll write it x cube first, then we'll differentiate x cube again, so this will become 3x square. We are differentiating x cube with the help of this formula d dx of x to the power n, and it will become x to the power n minus 1 as it is x cube. So this will become what? This will become 3 and x 3 minus 1, so this will become 3x squared. So that's how we are getting this. Okay, so final answer will be 3x squared sine x cube. Okay, let's move to the another example. So it will be example number 6. So this could be a question which will be a level of IGIDR. Let's say this is sec x tan root x. So you can see that here we have to apply chain rule for 2 times, because uh, here function has to be sec x, but at the place of x it is tan x, and inside the tan x the function is root x. Okay, So let's apply chain rule. So differentiation of sec x become sec x. So this is tan root x. Then we'll multiply sec x tan x. The form differentiation of sec x is sec x tan x. The tan of tan root x. Then we will apply differentiate this function, that is tan root x. So differentiation of tan x is what? Sec square root x. Okay, and again the function is root x, so we'll have to differentiate. Remember this one thing directly, because we can find the differentiation of root x with the help of the formula x to the power n, but just remember this as like d dx of root x equals to 1 upon 2 root x. So if you remember this, it will be slightly easy for you to solve this question. So this will be 1 upon 2 root x. Okay, so let's rewrite it in a slightly uh, simpler manner. So this will become sec tan root x into tan of tan root x into sec square root x and the whole upon 2 root x. Okay, moving to the next question. So I'm going to apply quotient rule. So this is question number 7. It is given that fx equals to 2x plus 3 upon x minus 2. So this is the question. So consider this as first function and this as second function. As quotient rule says, second function whole square, so here x minus 2 whole square, and then write second function, then differentiate first function. So differentiation of 2x plus 3 will be 2 plus 0, as differentiation of 2x will be 2 and differentiation of 3, which is constant function, so it will be 0. Now we'll have to write first function, then differentiate second function. So differentiation of second function will be 1 minus 0. Okay, now solve it. So it will come out to be 2x minus 4 minus 2x minus 3 whole upon x minus 2 whole square. So minus 2x will be cancelled out. It will be minus 7 by x minus 2 whole square. So this will be our final answer. Moving to next question, that is question number 8. So now I'm going to apply chain rule. So this will be y equals to sine 2x minus cos x. Okay, this is the question. So here you can see that I'm going to apply chain rule on trigonometric functions. So for finding differentiation, so this will be uh, cos 2x, differentiation of sine 2x will be cos 2x. Now we'll again differentiate 2x, so it will come out to be 2, and differentiation of cos x is minus sine x, and it is already here, it is 1 minus, so it will become plus sine x. So final answer will be 2 cos 2x plus sine x. Okay, so this will be your answer. So let's move to the question number 9, that is y equals to x power 5 minus cos x upon sin x. Consider this as first function and this as second function. Here I am going to apply quotient rule. So as per the quotient rule, the differentiation will be y dash. This will be sin x whole square sin x, and differentiation of first function, that is 5x power 4 minus, it will be differentiation of cos x is minus sin x, and minus minus plus, so this will become plus sin x. Now write the first function, so this will be x power 5 minus cos x, and differentiating the first function, so differentiation of sin x will be cos x. Okay, now let's solve it. So this will become 5x power 4 sin x plus sin square x minus x power 5 cos x minus minus plus cos square x whole upon sin x whole square. So here you can see that sin square x plus cos square x, this is the identity. So this will become 1. Here I am writing sin square x plus cos square x, this will equals to 1. So this will become minus x power 5 cos x plus 5x power 4 sin x plus 1 whole upon sin x whole square. So this will be your final answer. Okay, so let's move to the next question. That is question number 10. So let's say we have a given function, say y plus sin y equals to cos x. Okay, so here I'm going to talk about the implicit function. Implicit functions. So what is implicit function? This is very important. As we have seen that all the examples in which it was very easy to write function in such form, that is y equals to fx. But here in this case, it is not possible, as if you try to do it, so it will be very difficult. Okay, so implicit functions are those functions which cannot be represented in the form of y equals to fx very easily. So for finding the differentiation of implicit function, what we have to do, we will do it like that. So we will differentiate first y, so it will be y dash. Then we will differentiate sine y, so it will be cos y. Then differentiation of y is y dash, and then differentiation of sine x will be cos x will be minus sine x. Okay, so let's take y dash as common. It will become 1 plus cos y, and this will be equals to minus sine x, and finally we'll get the y dash, that will be equals to minus sine x upon 1 plus cos y. So this will be the answer. Moving to the next question, so that is question number 11. And here I'll also take some more examples of implicit function, because so many times I have seen that these kind of question has been asked in the sample set and in the my last year attempts as well. So xy plus y square equals to tan x plus y. Okay, so for finding the differentiation of this particular implicit function, we'll apply first we'll apply a product rule, then we'll apply x to the power n rule, then we'll follow the trigonometric functions rule. Okay, so this will become first differentiation of second, that will be y dash, then y into differentiation of x, that will be 1. Here in this situation it will become 2y, then y dash, because uh, as x to the power n rule, 2 will come ahead, and 1 will be subtracted from the power 2 minus 1. Okay, so this will be the differentiation. Then differentiation of tan x is sec square x plus y dash. Okay, so we'll shift this y dash term on the left hand side. We will get it xy dash plus 2y dash minus y dash, and this will become sec square x minus y. Now take y dash as common, it will come out to be x 2y minus 1 equals to sec square x minus y. Okay, so final value of y dash will be sec square x minus y whole upon x plus 2y minus 1. So this will be the final answer. So these kind of question can be asked. Moving to next question, that is question number 12. So as I have already covered several important topics here in this, like I have covered sum and difference rule, product rule, quotient rule, chain rule. Now I'm going to cover differentiation of log and exponential function. I have also covered implicit function. So now I'm going to cover log and exponential. Okay, so let's see. Question number 12 is y equals to e to the power x upon sine. Here it is exponential function and trigonometric function. So here we'll follow quotient rule. Okay, so as per the quotient rule, differentiation will be, let's say, y dash, and here this will be sine x whole square, and then sine x, that is second function, and then differentiation of first function to differentiation of e to the power x is e to the power x. Okay, minus, now what we will do, we'll write first function as it is, and we'll differentiate the second function. So the differentiation of second function is that is sine x, and differentiation of sine x is cos x. Okay, So this will be the thing. Now take e to the power x as common. This will become sin x minus cos x whole upon sin x whole square. Okay, so this will be the answer. Okay, now let's take another example, that is example number 13. So y equals to sine inverse x. Okay, although y equals to e to the power sine x. Though I have already shared the for all the formulas related to inverse function, but here I'm taking a single example of inverse function. The rest of the examples will be shared in the next series of this video. Okay, so now differentiating this, so this will become, as we know that e to the power x differentiation is e to the power x, so e to the power sine x. But here it is not x, so we'll have to apply chain rule. So we'll going to differentiate sine inverse x. Okay, so for that what we will do, we'll have to differentiate sine inverse x, and the differentiation of sine inverse x is and then 1 upon under root 1 minus x square. So this will be your final answer. Okay, so moving to the next question, that question number 14. Let's say y equals to log of cos e to the power x. I've already mentioned that chain rule is very important. Here you can see that in log there is a function called cos, then inside the cos there is a function e to the power x. So let's find out the differentiation. So differentiation of log x is 1 upon x. So this will become 1 upon cos e to the power x. Now we'll differentiate cos x. So differentiation of cos x is minus sine e to the power x. Now again we'll differentiate e to the power x. So the differentiation of e to the power x is e to the power x. So final answer will be minus e to the power x into sine x upon cos x will become tan e to the power x. So this will be the final answer. Now moving to question number 15. So it is y equals to log of log x. Okay, so again it is a kind of we have to follow chain rule. So now let's differentiate it. So what it will become, y dash log, differentiation of log is 1 upon x. So here it is log x, so we'll write log x. Now again we have to differentiate because of chain rule. Okay, so it will become differentiation of log x will become 1 upon x. So this will be our final answer. Okay, let's move to the question number 16. So here y equals to cos log x plus e to the power x. Okay, this is the question. So differentiating, it will become y dash, and differentiation of cos is minus sine x. So at the place of x it is mentioned log x plus e to the power x. So this will become log x plus e to the power x. Now we have to differentiate again this function. So differentiation of this will come out to be, differentiation of this log x will be 1 upon x, and the differentiation of e to the power x will be e to the power x. So this is the final answer. Okay, now let's move to the another example, that is example number 17, and it is y equals to x to the power sine. So these kind of questions are very important because these kind of question have already come in the IGIDR and also in the sample set. These kind of questions are there. So in this type of question, we'll have to take log on both sides. Log, taking log on both sides. So this will become log y equals to log x sin x. So sin x will come ahead and it will become sin x and log x. Why? Because of the property of log. If let's say log a to the power b, so this is b log a. Okay, I'm using this property here and this will become like that. Now differentiating this function with respect to x, so this will become 1 upon y and this will become y dash, and then this as first function and this as second function. So first function and differentiation of second function, that is 1 upon x, plus we'll differentiate this function, that is first we'll write second function and then we'll differentiate sin x. So differentiation of sin x is cos x. So this will become y dash multiplying y, and this will come out to be sin x upon x plus log x into cos x. Okay, and you can replace the value of y, so this will come out to be x to the power sine x in bracket sine x upon x plus log x into cos x. Okay. Okay, moving to the next question, that is question number 18. So in this question, this kind of questions are very important because it is being already asked in IGIDR Entrance Exam. We'll just have a look in this question. Here it is mentioned that y is equals to log x to the power x plus x to the power log x. So we'll split it into two parts, that is y equals to y1 plus y2. On differentiating, we'll get y dash equals to y1 dash plus y2 dash. So first let's solve it for y1. So this will become log x to the power x. So taking log on both sides, we will get x log of log x. Now let's differentiate it with respect to x. So this will become 1 upon y1, and y1 dash is equals to x will follow the product rule on the right hand side. So this will become x, that is first function, and differentiation of log x will become 1 upon log x into 1 upon x, plus we'll write the second function and we'll differentiate the first function, that is x, so it will become 1. So the final answer, when we'll shift this value y1 to the right side, and by putting the value of y1, that is log of log x to the power x, it will become this, which I have highlighted. Okay, now let's solve it for the second part. So that is y2, which is x to the power log x. So this is log y2. On taking log both the sides, it will become log y2 equals to log x dot log x. Because when you take the log, log x, which is in power, will come ahead. So this will become log x into log x, and ultimately it will become log x whole square. Now let's differentiate it with respect to x. So this will become 1 upon y2 dot y2 dash. And for differentiating log x whole square, we'll follow the chain rule. So this will become 2 log x into 1 upon x. And at the end, we'll shift y2 to the right hand side, and it will become y2 dash x to the power log x, because the value of y2 is x log x, we'll putting here, and this will be our final answer. So for final answer, what you'll have to do, you'll have to sum up the value of y1 and y2, which is mentioned in equation 1. So that is the thing. Okay, so moving to the next question. This question is x dot y equals to e to the power xy. So this question can be solved with the help of two methods. In method 1, you can solve the left hand part by product rule and the right hand part by using the differentiation of exponential function. But here we'll solve it by method 2. So for that, we'll take log on both the sides. So this will become log x dot y equals to x minus y, and dot that is product log e to the power e, and log e to the power e will become 1, and here we'll apply the property of log. So that is log x dot y will become log x plus y, and this will become x minus y. Now let's differentiate it with respect to x. So the differentiation of log x is 1 by x, and the differentiation of log y will be 1 upon y dot y dash, and here differentiation of x minus y will be 1 minus y dash. Now let's take all the y dash term on one hand left hand side, and shift 1 by x to the left hand side. On solving this, you will get x minus 1 upon x multiplied by y upon x plus y. Okay, so this is the thing. Now moving to the last question of the session, that is very important, because such kind of a question can be asked, and these kind of question have also been asked in the last year exam. So this is cos x to the power y, which is equals to cos y to the power x. So taking log on the both the sides, this will become y log of cos x, and here on the right hand side, it will become x log cos y. By applying product rule on the both the side, we'll get this. So y will be our first function, and log cos x will be our second function. So this will become first into differentiation of second function. So we're differentiating log cos x. So this will become 1 upon cos x multiplied by minus sin x plus we'll write second function as it is and we'll differentiate the first function. So this will become y dash. And here on the right hand side we'll differentiate it. So we'll write first function and differentiating second function. So this is log cos y. So this will become 1 upon cos y, and differentiation of cos y will be minus sin y, and we'll again differentiate y. So this will become y dash. Now we'll write second function as it is and we'll differentiate the first function. So this will be 1. Okay. Now let's solve it. So by simplifying, we can see that here cos x and this minus sin x. So the minus sin x upon cos x will become tan x. Similarly here minus sin y upon cos y, this will become tan y. So let's arrange all the y dash term on the left hand side and rest of the term on the left hand side. By solving this, we'll get the final answer, that is log cos y plus y tan x plus log cos x uh, plus x tan y. So this will be a final answer. So thank you from my side. And if you are preparing for IGIDR's 2021 entrance exam, so you can enroll in our classroom program. And if you like this video, so please share it and give press the like button. And you can also subscribe this channel for more updates. And we'll very soon will be launching the video series of the solution set of sample paper which is being provided by IGIDR. So thank you everyone. Stay safe, stay healthy.